Welcome back. Let's talk about types of faults. Faults is where a break in movement occurs, along which energy is released. This is known as an earthquake. So when the plates of the earth break or interact and move relative to one another, they do so in a few different ways. Now, again, these are different than boundaries. These are when there's break and movement, which can occur on or near a plate boundary, or sometimes even far away from plate boundaries. So let me just list off the types of faults, and I'll go through how to distinguish all of them. So first off is something called a normal fault. That's created by tensional stress. So something pulling to create this break and slippage of Earth's material, creating a normal fault. You have a reverse fault, which is a reverse of the previous scenario. So you have a compressional stress, so crashing together, causing material to break and move. Compressional stress causing reverse faults. Then we have strike-slip faults. This is caused by a shear stress, kind of a side-by-side motion. Now, there's a fourth type called a thrust fault. It's just kind of a special case of number 2, compressional stress. So you might be saying to yourself, well, tensional stress, compressional stress, shear stress, isn't that all related to divergent boundaries, convergent boundaries, and transform boundaries? Yes. But remember, a fault is not necessarily the boundary itself. It's a breakage of material, which could be on or near a boundary, or sometimes even away from a boundary. So breakage and movement. So tensional stress causes normal faults, so that's kind of more indicative of something you would maybe find near divergent boundaries. Compressional stress, if you find a reverse fault, most likely you'd be looking at an area that exhibited characteristics close to that of a convergent boundary, so maybe near a convergent boundary. And then shear stress of a strike-slip fault, indicative of something being near or on a transform boundary. So how do we distinguish the two? Distinguish them just by look. We have to look at something called the hanging wall versus the foot wall. Hanging wall versus the foot wall. And so let me give you an example before we proceed. So here is Earth. Here's some layers of the Earth if we're looking at it from the side. Imagine the Earth broke and movement occurred. That would create a fault. Now, along either side of that fault, we have 2 blocks or 2 walls. We have a hanging wall and a foot wall. How do we distinguish that? Well, the hanging wall, if you look at it, the hanging wall kind of has a like overhang. It kind of has a little bit overhang. You could imagine someone grabbing on and hanging from this side, called a hanging wall. Well, the foot wall is the opposite of that. A foot wall, you can imagine this would be the side that someone could walk down if at this fault these 2 blocks were separated. Maybe it kind of looks like an elephant foot as well. However you got to think about it. So to distinguish between types of faults, it's probably easiest to look at the hanging wall. And what does it do? Does it go up relative to the foot wall? Does it go down relative to the foot wall? Different stresses will cause different motion. So for instance, if I were to create compressional stress, so I'm going to push inward. Okay. So as I was pushing inward, that movement occurred, the hanging wall went up. So due to compressional stress, the hanging wall moves up. Compressional stress causes reverse faults. If I created a tensional stress, kind of pulling apart, relaxing the pressure I apply to it, I'm kind of pulling my hands apart, then that hanging wall fell down. The hanging wall falling down creates a normal fault. So kind of depending on which direction the hanging wall went relative to the foot wall will help you figure out what type of fault you got, therefore what type of stress you have, therefore possibly what type of ancient boundary environment this fault area may have been near. So again, if you have a hanging wall going up, this little arrow represents it's going up relative to the foot wall along this fault, that's due to compressional stress, it's a reverse fault. The opposite of that is when the hanging wall drops relative to the foot wall, that's due to tensional stress or something being extended, and that creates a normal fault. Now, strike-slip faults, there really is no necessarily up and down movement. It's all just side to side. So if you're kind of looking at it from the top, it's just kind of side by side. There's no up, there's no down. It's just more kind of towards and away, towards and away. So it's a shear stress causing this strike-slip fault. So that idea of hanging wall and footwall goes out the door when we're talking about strike-slip faults. Now, where did these names come from? It actually came from mining. So a lot of times when you're old miners, or even now, mining now, you're looking for faults. The reason being, if there's some break and movement of rock, that means there might be some gap in between those rocks. And if there's gaps in between those rocks, that allows for mineral-rich water, mineral-rich magma to kind of make its way through these gaps, depositing valuable minerals, and thus miners can go into these faulted areas to mine out these veins of mineral-rich material. So the way the miners kind of distinguish the two sides of the fault as they were kind of in the mine itself, kind of mining out the vein, the side that they hung their lanterns from, well, that was the hanging wall, where it got its name. So it has that overhang, it went over their head. The part that they walked on, that was the footwall. That's how that worked out. So here's a great example. This is up in Utah. So you can see the fault right here. And in this case, this top block is the hanging wall because it kind of has this overhang to it. And so which direction did it move? Well, we got to kind of match the layers. It looks like these kind of fine layers were once matched up with these layers here, but now it looks like they got pushed up. So the hanging wall went up, so making this a reverse fault. This is a picture I took not too long ago. It's up in Utah, and just to give you reference of this area, it's called the Katabi Knob. Excellent little place in the middle of nowhere. That's about how tall I was. So this is a big chunk of stuff. This is a big fault that got thrusted up, millions of years ago. So let's take a look at another example. Here's the fault. We can see the breakage and movement. No, that's not me. Here's the hanging wall because it has that overhang to it. It kind of has that little tilt overhang to it. And it looks like the hanging wall went down relative to the footwall, which looks like it went up. So we have the hanging wall went down, therefore that is a normal fault caused by tensional stress. And then when we have something like this, this is looking down like from a kind of like an airplane looking down onto the flat ground. In this case, you don't necessarily have any up-down movement. This is more side by side. So here's the fault itself, okay, right here, and it looks like, kind of we have white, red, yellow layers, red, white, yellow layers, red, white, yellow layers. So this is not a normal fault or a reverse fault. There's no up and down movement. This is all side by side motion. It looks like this top part, the part just above the fault went to the right. The portion below the fault went to the left. That's making this a strike-slip fault. Before we get out of here for this video, let me give you the first part of the super secret code. That is the number 5. The number 5. You got me? Number 5. All right, we'll pause there. When we come back, we'll talk about these ripples of energy that radiate through the earth, which causes the ground to shake in an earthquake. We'll talk about seismic waves when we come back in just a minute. See you then.